Good morning, everyone. Am I audible? Yeah. Good morning. Good morning. Great. Okay. Okay. So, first of all, any doubts from last time? Good morning. Good morning. So, any doubts from last time? See, today we don't have much to do, so we can spend a little more time on question answer and doubt solving. Uh, just couple of main topics for today. We stopped at ANOVA last time. Okay. So, I'm assuming there are no doubts. Even if you have some, we can always do it after we finish today's content. Um, and I hope everyone's enjoying Navratri. Oh, one sec. Is it better now? Okay, great. Okay. Um, yeah. So, anyways, ANOVA, there's a couple of more things I want to explain, and then we'll move on to ANCOVA. Basically, see, first when we tried to, sorry, there are a couple of birds fighting here. That's the disturbance. I'll just shoot them and come. Sorry. So, yeah. So first, I just want to explain why we did the ANOVA first and then the t-tests, right? This is one thing you need to kind of understand. So, ANOVA is usually performed on at least a group of three you need, okay? You need at least three variables, right? Like we have three streams of advertisement here. You need at least three to be able to perform ANOVA, okay? The t-test is basically to compare two together, right? So what the ANOVA told us was whether there is a significant difference between these three streams or not. Only if there is, then you compare each of these, right? Now, the t-test, there's a kind of hidden danger here. Why we do this ANOVA first and then the t-test is because let's say our significance, right? It should be 95%, right? Yes or no, guys? 0.95, or the confidence level as it is also called should be less than 5%, right? Yes or no? You all remember that? Hello. Mm, I'm talking about this one, right? this should be less than 5%, right? 0.05. Oh, okay. I thought I wasn't audible for 1 second. Okay. So basically, there's this interesting thing that comes up. Suppose uh, I base my judgment only on t-tests, right? And I don't do ANOVA, right? Um, Now, if I simply take this 95 and let's take these three streams, and suppose I just multiply the 0.95 three times, right? Into 0.95 into 0.95. Okay. Now, instead of 95, you'll basically be testing for this 0.85. So the confidence level has gone down. Okay. So as you can see, it's basically more error prone now. Okay, it's little less confident, right? Almost 10% more. Okay, so that's why you basically do the ANOVA first and check if there's any significant difference. Then to compare two of these, you basically use the t-tests. Is this clear? So no, guys. Okay, so that was it for ANOVA. And if we go into the presentation, it says the same thing. So yeah, if you have this PPT already, it's from the LMS, right? Um, you can read through all this on your own also. I'm not taking you through this. This is what we basically did last time. Okay. Um, yeah. So it relies on these couple of assumptions. Uh, yeah, Vishal, do you have a doubt or you want to ask something? Vishal, you want to ask something? Okay. I'll just mute you then. Guys, mute yourselves, no, please. Oh, okay, no problem, Vishal. It's okay. We've just started. Yeah. Okay, so ANOVA basically follows these assumptions. Um, okay, so these subgroups, basically these three streams in this example come from normally distributed populations, right? So this is obviously for any statistical analysis. It should be part of a normal curve, right? As we saw in the first session of stats, how important the normal curve is. That same thing applies here also, ANOVA, right? If it is not following a normal curve, obviously it is not statistically significant, right? Um, and the subgroups can be compared having equal variances. So the variance for each of them should be approximately equal, right? Only then the ANOVA will make some sense, right? So as you can see, the difference between groups, right? Right now it's showing a good value, but if you just check the variance, see, most of this is same. Only this one is very different because 1 second. Because if you see the numbers here, so if you just do a simple sum, for example, right? Actually, I'll show you a quicker way to do sum. Okay. So okay, sum does not show much of a difference, but day to day there's more variance here in the newspapers. That's what this is trying to say. Okay. Uh, That's it. So some other use cases for ANOVA could be comparing gas mileage of different vehicles, right? Or the same vehicles under different fuel types or road types. Understanding the impact of different medications on the treatment of some disease, right? Studying whether advertisements of different kinds show different kinds of responses, right? Uh, from your own field, can you give out one or two more examples where you might use ANOVA? Can everyone do that quickly? So basically, anywhere you have some sort of variance, two kind of measures or categories, then that is when you can analyze the variance. Okay, Arnab says different sales throughout the year based on months. Yeah, that's a very good point. Yes, yes. So basically, Arnab, you're checking for seasonality, right? Okay. Anyone else? This chat box also should show this one is typing and that one is typing like WhatsApp does. So I at least know if you're thinking or writing down the example. Anyways, I'll just move on to ANCOVA. Okay. Mm. So basically, ANCOVA is little. It's like an extension of ANOVA. Okay. Um, ANOVA is analysis of variance. ANCOVA is analysis of covariance. Okay. Now the difference between variance and covariance, or rather correlation and covariance, is basically correlation is uh, based on two sets of numbers, like we've seen already, right? If I just move to the correlation sheet here, so two sets of numbers, right? We basically see the correlation between just these two numbers without considering any external factors that might affect them, right? Now, Ankova will basically go a step further, and it will also see how external factors might affect these two variables. Okay. So, what I mean by that is if I just go to this Ankova one sheet, okay, this is still an analysis of variance, but it also takes into account external factors, right? So if I just okay, I'll just show you this example first. Then you'll understand it better. So these two, by the way, you'll find this in the week one sheet. Okay, uh, the week two sheet I generally don't use for statistics because some of the sheets are missing in that. So I generally use the statistics 101. Just go back to that and open it. Right. I think you'll already have it because you've been using that for the first week of stats. Okay. Uh, anyways, so these two tables here are basically scores for a class, right? There are four different methods of teaching that we want to analyze. Which method of teaching is best, right? So we've listed down. We've basically divided the class into four and given each student, each group, different method to teach. Their different method of teaching, right? Now, once this is done, we also want to check for how their income affects these methods, right? Now, this would, if we were checking only for the scores based on teaching method, ANOVA would be a perfect like solution to find out the significance of this, right? But we also want to check if income has any effect on the scores, right? So, for example, if you take a subject like English, right, and if a certain student is from like a vernacular school where English is not taught as the main language, and at home also they don't really speak English much, right? Um, so your income also affects. So if the parents are poor, okay, you see this a lot in India. If the parents are really poor, they don't really know how to speak English, or they're from the village somewhere. Um, and yeah, basically they're in. Okay, if they're from the village, it doesn't mean their income is bad, but maybe they just don't speak English, and that will affect the scores, right? So that could be another variable that we measure for. But in this example, we are just sorry, that will be another covariant. Variable is the wrong word. Um in this, we are just checking the variability for the scores based with this one covariate of income. Okay, is this clear? Is the example clear to everyone? What we are trying to do here? Yes or no? Okay. So now, basically, okay, before I start, if I go to the data tab and I go to data analysis, you will not see ANCOVA here. Okay, you will just see ANOVA, right? Because the thing is, ANCOVA is a little more processor heavy. It's not like built into Excel. So what you have to do is go into this website. So this is an add-in made by a third party. He's made it for himself, but he's kept it free for everyone to use. Okay, so you can go to this website and download the add-in. You can do this later. You need not do it now. For now, just understand what Uncova is. So someone has used that same add-in and done the Uncova here. Uh, so basically here the key number is the significance f, right? Just like we had p-value over there in ANOVA. Okay. Just like we had the p-value here, ANCOVA में the same value is the significance f, right? This means how significant a difference there is. So again, if this is below 0.05, then it is worth looking into. Okay, is this clear to everyone? I'll just take you through the how to go about the add-in in a bit. But is the concept clear to everyone? Okay. So like this, like we have the income covariate, you can also go on adding other covariates that you need to measure for, right? Okay. So if you go on the website, if you just click the link, I have it open here. You go to the free download and you go to resource pack, I think. Actually, the button is right here. See, a real statistics resource pack. Just click on free download, or you go to the page and say download. Right? It has instructions here. If you need to use Uncova, please use this add-in. Okay, and it will basically look like, so you'll have to turn it on also like this. X real stats, right? You just turn this on like we've done for the other add-ins, and that's about it. The instructions are all here. Okay. And by the way, this add-in has a lot of stuff for statistics, not just Uncova. Okay, so you could use this for a lot of things. Just download that now if you want, and you can try out Uncova. Okay. This add-in is created by this guy Charles. Guys, do you want to try the Ankova out first, or should I just move on to regression and then you can like spend the rest of the time after the break trying Ankova? Just let me know. Okay. Okay. So let's move on and then we'll spend like after the break on trying out stuff. Okay. Fine. Okay. So basically, trend line analysis. Um, Before that, I'll just show you this thing, portfolio analysis. Just to explain how the graph works, right? How the trend lines work. So, for example, this data is like sample data for Bitcoin, right? And we've just made a simple line graph showing the Bitcoin price on that particular day, right? Um, that's about it. And as you can see, it like starts off slow and just goes really high and then comes back to a little like a middle position, right? Now, if you want to add a trend line, all you have to do is go to format, chart design, and you go to add chart element, and you just go to trend line and choose one of these, right? So if you choose a linear one, it'll add this linear trend line too. So as you can see for this data, the entire data shows this Bitcoin is going towards a higher position, right? Try out the trend line guys quickly. And there are different types of trend lines. There's exponential, there's linear, forecast, and moving average. The linear and exponential is where you'll see the most difference usually. Okay. Done everyone? If you want, you can add both also, the exponential and this. By the way, for stocks, there's a whole theory called the modern portfolio theory, which basically uses statistics for like to optimize your stock portfolio, right? You should read up on that at Investopedia or something. Just Google modern portfolio theory. It's an interesting read. So if any of y'all are actually actually invested in the stock market, you should really go through that once. Okay. Is everyone done with the trend line? Yes or no, guys? So trend line, what basically it does is it will try to find some straight line. So I'll just remove the exponential one. Okay. So the trend line tries to find some sort of straight line, the linear trend line, some straight line where all this noise is kind of so. Uh, if you see these peaks and small peaks and valleys, they are called as noise, right? Noise because they don't really tell you much other than what actually happened on that day, right? They don't tell you much on direction, right? But if you just put a trend line, it will basically reduce all the noise to one single line that can be uh, basically thought of like it's not an average, but it can be thought of like an average direction. Okay, um, as to where this is going, right? Um, and of course, we've already seen what the variance is, basically the distance from the mean. But in the case of regression, it is the distance from this best fit line, right? So the trend line is also called the line of best fit, right? Because it is a line that is drawn such that it will fit all of these small data points perfectly, right? As close to it as possible, as close to all the data points as possible, right? Is this clear to everyone? And obviously it is not an average because an average would be one single value, right? It will be a horizontal line. Okay, is this clear to everyone? Okay. So right now we have data points for 365 days, I think, or a little more. So yeah, all of this whole year's data has basically been put into one single trend line. That's how easy trend lines are to use, right? And they give a very good visual indication of what regression looks like. Okay. Now, now regression is nothing but trying to find this best fit line using maths, right? So in this particular example, um, there is an x variable and there is an expected y variable, right? And we basically need to find out what the regression statistics say about this, right? Okay. Uh, Now there are a couple of things to tell you here. This thing called coefficients and intercept, right? Um, so if you see this trend line carefully, at some point it'll basically intersect the y-axis, right? Can you see that? Can everyone hear me? Okay. Okay. So I think Madan will have to check the recording. Anyways, so if you can see at some point this trend line basically intersects the y-axis, right? Right now it's at 0, okay? But sometimes it may be high up here, okay? Um, yeah, so basically that is called your intercept value, okay? Your intercept, as in the place where the y-axis meets the trend line, okay? Then you can also visually see there is a certain slope to this, right? There's an angle to the whole trend line, right? That is called your slope in regression. So if I go to regression, this thing here is a slope. I know it's not written here, but this is the slope value. Okay. So when we calculate regression, there are three ways to do this. One is through a chart, which is trendline analysis. The other is through the data analysis pack, and the third is through formulas. Okay. So if I say intercept, uh, I'll basically get this same value here. Okay. But let's just see all these methods one by one. Okay. Now, if I just actually let's just see. Okay, let's go to data analysis pack and see it through there. So if I go to regression, right, I can actually put these two values. Someone has put the whole column. I'll take the labels also because I want the labels to come up here. And this one will basically be this. If you want to customize the confidence level, let's say you're in an industry where 95% may be too dangerous, you can actually choose a tighter confidence level, maybe 99% or 98%, right? So this is where you customize it. How accurate do you want the regression to be? Okay? But generally 95 is a good default percentage that everyone uses. Okay? Um, Right now I'll just put this in a new worksheet and I'll just turn on all of this so that we can see what all this regression part comes up with, right? So this will just create a new sheet based on that same data. So you get a few plots here with different numbers given. You don't really have to pay attention too much attention to these. The key values here are the R square. I'll just highlight these. Okay. The R square value, which basically is similar to the P value. Okay. Oh, is it? One second. So Dipto, let's go back to data. Oh yeah, sorry, my bad. So input Y goes first, right, with the label, and the input X. Yeah, thanks Aditya for pointing it out. Yeah, labels are on. Yeah, okay, okay. So the main values here are the R square, which is similar to the P value, meaning this is basically a number between 0 and 1, and the lower it is, the better it is. Um, so, because we had a confidence level at 95 percent, if this is less than 5%, then it's a good fit, right? It's a very in this case, this is a really good fit of regression that we've got, right? So that is the R square value. Um Again, you have the significance F here, which is kind of like the ANOVA and ACNOVA, right? You remember these, right? Hmm, ANCOVA. Yeah, the significance F, right, from the ANCOVA sheet is the same number out here. Okay. If I go to sheet 4. So again, this tells you how significant the difference between each group is. Um, so right now it says it's not much of a difference. That's why there's like such a good fit. Okay. Usually, if there's a lot of difference, then the R square value will be a lot higher, right? Um, okay. Then you have the intercept and the slope values, right? Which is basically again about the trend line. So if I go to the portfolio analysis, intercept is where the trend line meets the y-axis, okay, and the slope is the angle of the actual trend line, right? So that is how you kind of read these two numbers. And then, okay, I don't think I should explain residuals because there's nothing you can infer from it. So residuals are basically if I go to variance, you see the differences we kind of calculated from the mean. Okay, the same thing kind of applies here. So if I go to residuals, it will basically try to find out what's the difference between the first observation and the R square, the trend line value, the R square value. Okay. Yeah, that's about it. I know this looks super complex, but if you just remember few uh, these four numbers, then you should be able to read this properly. Okay. Personally, I prefer a simpler way to do this, which is trendline analysis. So if I just use this sheet only. So if I just make a plot based on this, just make a scatter plot. Mm, Even one without a line will do. Then you just go to the add. If in newer versions you can just use this plus here and go to add trend line. Okay. You can also go to chart design and add the trend line here. For now we'll just use linear ones. because okay, one thing I forgot to tell you was Excel is kind of limited to linear regression. Okay, so even through the data analysis pack, you can only get linear regression. You cannot get exponential ones because see, this is not a statistical software, right? You could do this in Python or R or even SPSS, but not in Excel really, right? But you can generally do the simple linear regression very easily. So now, as you can see, a trend line has been made, right? And if you just right click and go to right click the actual trend line, you'll have to be a little careful on this. And you go to format trend line, okay? You'll get this panel over here, right? Uh, this is the easiest, quickest way, the most common sense way to do regression, okay? So basically, you can change the type of uh, uh, trend line this is, okay? But we won't get into that. We'll stick to linear. Uh, and you can see you can actually display the equation and the R value on this chart, right? So what the equation is, I'll just tell you in a minute, okay? But the R value is again the value of how well this is fitting, okay? Yeah, if I just go back to format trend line. Now for forecasting, this is a very like easy to use and very accurate uh, kind of feature. If I say, let's say I want to know, okay, so I'll just explain this data first. Uh, we have this data for AA battery cells, right? And we've basically uh, taken a lot of samples and seen how many chances of failure there are on day zero, right? On day one, on day two of use, right? Like that up to 99 days, we found, okay, on the 99th day, there is about 62.8% chance of the battery failing, right? So now if we want to extrapolate this and want to find out how this will work beyond 99 days, then you can just, I think this data is, okay. So then all you have to do is go to the format trend line, okay, and you go to the forecast values and you say forward how many periods, right? So let's say I want to know for 50 more. I'll just put I'll just put 5 for now, okay. Um, Actually we need 50. So as you can see, at about the 100 mark, the chances of failure are at 60%. At about 140th day, they almost become like 90 plus percent, right? And at about 150 days, uh, it's 150 days of use, there's almost about 100% chance of the battery failing after 100 days of use. Okay. So this is how you can use like this linear regression through this trend line, right? Is this clear to everyone? Any doubts? Yes or no, guys? Okay. So coming to the equation, if I just run through the mm, yeah. So yeah, this slide. Okay. So there are two types of variables, right? There's a dependent variable and there's an independent variable, right? Now, in simple linear regression that we were trying to do, there's only one independent variable, okay? The mx, right? So, any kind of regression basically tries to boil everything down to this kind of equation, right? Um, Similarly, you also get, this is not available in Excel, but you also have multivariate linear regression where there are at least two independent variables, right? Is this clear to everyone? Okay. So that's the whole part of the equation. If you understand algebra, you could go into what the numbers mean. But if you don't, the just doing the trend line analysis is perfectly fine. right? You could also get this through doing the formulas, which is intercept and slope. Okay, so intercept I'll just say my y's and my x's, and that will give me a certain number. And if I go to slope, again I put the same numbers in, and this kind of works like like how the Corel formula works, right? The correlation formula. So this is a slope and intercept. That's about it for regression. Um, if there's any doubts, you can ask. Otherwise, there's just one more thing left for me to explain. We could perhaps do it after the break, right? Um, in the meantime, you can try Ankova. Just download and install the add-in over here. And yeah, let's take a break now. Okay, let's meet back here at 11 o'clock. Is that fine with everyone? Okay. If you have any doubts, you can ask me now. I'll just wait for a minute. Okay, Arnav, I'm not really there on social media much. Okay. So LinkedIn, I think I made a profile sometime back, but not checked it at all. So I'm kind of forced to be there on WhatsApp because everyone is there. All my clients are there on WhatsApp. So there's no escape from that, but at least all the other social media I'm not really there on. Okay. Okay. I hope everyone's back. Is anyone back? I have no idea. Um, Amit, I don't think you'll have to worry about attendance. You can ask your coordinator though. He'll be able to help you more. Okay, Amit? So now maybe you can finish the Encova. Just try to download and use this add-in. In the meantime, if any of you have doubts, questions, you can ask. I have just one more thing left to explain, which is principal component analysis, and then we can stop. Just let me know when you're done with Encova so I can move on. Okay. Guys, can everyone update where you are with the Ankova thing? With the add-in? Are you still downloading or installing, or you've tried it already? Guys, just update me please, so I know if I can move on. Okay. Arnab is done. Great. What about everyone else? Just update, please. This is one more concept I have to explain, and then we could stop, or like go into doubt solving questions, whatever you have. So Arnab, were you able to run the Ankova properly, like this one? Okay, great. Okay, I'll wait for a couple of more minutes for the others to finish. Okay. Um, Guys, just pay attention. Even if you're doing the Ankova thing, just pause for 5 minutes. I'll explain this next concept and then you can continue. Okay. This is the last concept we have to kind of look at. Um, this concept will kind of make bridge the gap between statistics and like a real world numbers that you see around you. So this is called principal component analysis. Okay. Now this fancy word, all that it means is giving certain weight to see every. Let's talk about the same example. Okay. Now any student will have many covariants that can possibly be there. One is the income at home, right? One is the language they speak at home, okay? The level of education of their parents or their tuition teachers, right? A friend circle. There are so many covariates that can affect the scores of the student, right? Yes or no, guys? Come on, guys. Yeah. So principal component analysis, all that it does is it will actually allow you to put a certain weight behind each variable. Okay. So let's say variable 1 is very important. So I'll put that really high. Okay. Sorry, this is high, right? And the other variables are not very high. So this right here is just a visualization for you to see and understand. Excel is not possible to do stats with principal component analysis, but any statistical software like SPSS or R will let you do this. Okay. So as you can see, the most weight is given to variable 1. Um, so whatever the variable 1 is, it kind of has a multiplicative effect on that. So if I reduce this a lot, okay, and keep the others very high, okay, uh, as you can see, they kind of balance out uh, um, whatever the weights are. So um, for example, in this same example, right? Let's say the income is not such a big decision maker on the score of the student, right? Because we have plenty of examples of poor students who even study. Uh, this is a favorite example of for parents. They study under the street lamp and still pass with high marks, right? So maybe we will not give so much of weight to the income, to the family income of the student, right? Maybe we'll give it 20% of weightage. Um, Maybe a much better covariant for this must be the friend circle, right? Because at that age, if the friend circle is kind of studious, the student himself will be lean a little more towards being studious, right? But if they're all like party goers who don't really study, it's a very high chance that this particular student also will not study and will be more like them, right? So in that case, the friend circle covariant, you might put a lot more weight behind it, right? So PCA is kind of difficult to do in Excel, but what you can do is something called as weighted averages, okay, which is what I've made here. I'll just put a few numbers, okay, and these are just some formulas. They just add up whatever's on top, okay. So I'll just put these random numbers, and I've assigned some weightage to them, okay. Now the weight 1 basically adds up to 100%, okay. Now if the weight adds up to 100%, um, see, without weightage, the average comes up to 50, right? But if I use the formula for weighted average, you will see with these weights applied, the average for these same numbers is 27.5. It's a big difference between these two numbers, between these two averages, right? That is simply because I've put a lot of weight behind this number 10 and not much weight behind this the highest number here, right? So this will not be accounted for too much, right? So I'll just show you what the formula is. It's some product. You all have used this, I guess. So all it does is it'll just take two arrays and multiply them. And because my weights are in percentages, they'll just like kind of work. They need not be in percentages compulsorily, but if you're using just the sum product, it has to add up to 100%, right? Percentages are usually the best way to give weights. Okay. So that was your weighted average if your weights add up to 100%. Is this clear? Yes or no, guys? So all that is happening behind the scenes is this gets 50% of the weight, right? This gets only 5% of the weight, right? And yeah, and if you have weights like this where it does not it does not go up to add up to 100%, then all you have to do is do the usual sum product, right? And then just divide by the sum of the weights. Okay, that'll give you the accurate weighted average for if it does not add up to 100%. Okay. So if you want, you can change the weights and see. So if I make this 200%, you'll see the weighted average 2 changing here. See, is this clear to everyone? Yes or no, guys? Okay. If you want, you can try the you can try the weighted average part at least because you can just it's possible to do in Excel. I'll keep the formula open here. This is the last concept I had to kind of explain. Um, yeah, if you all have any other queries, doubts, you can ask. Otherwise, we can close the class session for today. And I think now you will be able to do the assignment for the 9th week. Yeah. Oh, you already did it. Okay. It was simpler than the first 8th week, right? Just two questions. Sudipto, it's okay. You can send it to your coordinator. It's fine. Oh, you want me to do check it now live? Okay. So I'll just let you share your screen. Yeah, Sudipto, you can share your screen. We'll have a look. Yes, Vishal, this is the last class of stats, which is why we are winding up early. We have finished our. Sudipto, we still can't see your screen, by the way. Yeah, now we can. In the meantime, I'll just copy the feedback link for the stats classes. Okay. Okay, great. So Sudipto, have you put like stepwise what all you did you do? Because the question says using the stepwise method, right? So I know it's very simple, but you just put stepwise what you did. Like you created a chart, you added a trend line, right? By the way, did you do it just now in the break, or you already knew how to make the trend line? But this seems okay. Yeah. Show me the second answer since you're here. Oh, okay. YouTube Zindabad. Okay. Second answer, please. Okay. Oh, you graphed it also. Fine. So you use the correlation data analysis pack. That's fine. You can also use the Corel function for this. But this is also perfect. Yeah. Just mention the steps that you took. That's the only thing that's missing from you. Okay. Okay. Great. Anyone else? Any other questions? Welcome. I'll just paste the feedback link for stats classes. It's a long link. You can always ask in the Q&A forum. Okay, there are people who answer over there. In case they are not able to solve, then they'll forward it to me anyways. To me or some other trainer. Okay. Yes. So I think next up you all will be learning SQL, Power BI, and then you will have the capstone project. Sorry. So the capstone is really interesting. If you want, you can start solving the Excel bits of it, Excel and stats also from the capstone, from whatever you understand. Guys, do you all have any other questions or doubts? Otherwise, we can close this session for today. Okay, you all have finished SQL and Power BI. Oh, okay. So then next will be capstone project directly. Great. Okay. So in fact, you all should start at least getting an understanding of the. Just go through the LMS for the capstone project, right? There'll be a document explaining the data set and how what all you have to do to prep it. Once you understand the data set, then you can start solving at least the Excel questions. They're very simple to do. Okay. Yeah. Yeah, we are done for stats. Yes. Unless someone has something to ask. If you don't have anything to ask, you don't need to wait. You can leave. Vishal, next class would be, since you all have finished SQL and Power BI, it will start with the capstone directly. Okay. So don't wait for the next class to start the capstone. You can start it on your own. All the explanation is there in the LMS. The capstone is more for you to like solve and like get your hands dirty with. Okay, that will actually help you understand how much you've learned, right? Uh, yeah. How long? That you'll see it in the LMS. How many questions are there? Okay, that's what I'm saying. Start as early as possible so you can finish by in a week or two. Okay, it's not difficult per se. It's just new, and you'll be using, oh great, you already started. And you'll be using everything that you've learned in the course in the capstone. So yeah, it'll be a good revision also. And by the way, the capstone is designed in such a way that it's very close to real world projects. Great. Has anyone else started the capstone? Yeah, it's like doing a real project, yes. But actually, it's simpler than a real project because the questions are given ready-made to you, right? Um, in a real-world project, your boss might just tell you, just find out this and this, and you will have to think up the questions also. So, in fact, in the capstone, you should pay more attention to how the questions are asked, and you should see if, ideally, you should see if you can create more questions on the capstone. Okay, just by using common sense, you can create a lot of questions also, right? As you yeah. Bye, Rajan. Happy Dasera to all. Yes. Anyways, I was saying, yeah, as you understand the data set deeper and deeper, you'll automatically come up with newer questions. Just write them down somewhere or share it with your trainer or whoever it is. Yeah. Okay. So, guys, I don't think anyone has questions regarding stats. We can close the session now. Uh, Bye, everyone. I'll just paste the feedback link one last time. I think it's lost in the chat. Make sure you give me a whole population full of feedback here. Uh, yeah, that's about it. Bye, guys. Happy Dasera. I'll just end the meeting in a minute. Welcome. Oh, is it? Wait, I'll just try and copy it again. Uh, one second. Yeah. Guys, try this link. This one should work. Just copy paste it. Oh, okay. Unable to select the very good option. Okay. Okay. That's weird. That should not happen at all. Poor trainers. We won't be able to get very good rating. Okay. Anyways, this new link should work. If it doesn't, just get in touch with your coordinator. Okay, I'll close the meeting now. Thanks everyone. Bye.